Okay. All right, so last time what we started doing, remember, was we were looking at systems of linear equations. And remember, we're looking at two equations in two unknowns. You know, the variables are x and y. And since they're linear, you can also see that the exponents of x and y, each of those are 1. Both of those are 1. Now, I want to say you can look at a system of equation, excuse me, where the exponents are 2 or higher. However, I'm definitely not going to look into that for the class, that is, mostly because I figured it's good enough to focus on this. So, but what you could also do, I'm not sure if the book does this though, you can look at more equations with more unknowns. You could look at, for instance, 3 equations and 3 unknowns. I mean, for time consideration, I'm not going to cover that. And also to graph that, you would have to be able to graph in 3 dimensions. As fun as that is, we're not going to do that though. So this is basically what we're going to look at. And remember, a solution to a system, it's a solution to both equations. In other words, it has to be a solution to each of the equations. And in this case, our solutions are going to be ordered pairs. Now, we did go over substitution last time. What we will go over now, I mean, we did mention Desmos and graphing. And here with graphing, what you want to you have a solution if the two graphs intersect each other. In other words, solutions can be found by graphing. You're looking for points of intersection. You know, points where the two graphs of these intersect each other, if any. You know, they may not intersect, as over here, which I'll get to shortly, or you may have one graph overlap another one. But points of intersection, those are the solutions. You know, again, you have to be a solution to both equations. Graphically, the point has to be on both lines. Hence, you want points of intersection. Okay, let me just go through again how to graph this. I mean, again, in this class, since we're online, I'm not going to ask you to graph the equation. I'm not going to ask you to sketch the graph of these by hand. You know, I'm not going to do that. In class, I would, but not online, not virtually. So I'm really just going to use graphing here, mostly as like a check, so to say. Like you could check if your answer is right by graphing. And what I'm focusing on is substitution. And I'm also going to show another method today, which is the method of elimination. Okay, so anyway, let me just get the Desmos also. So let me just, here, let me get to the site, then I'll share it. Here we go. You know, again, Desmos, it's free, which is very nice. So, okay. All right. So if we were to graph these, let me get to Desmos. So I don't know how to share 2 things at once, if that's even possible to share 2 things at once with Blackboard. There might be a way, I just don't know. But you do have the notes in front of you. I emailed the notes to everyone. Okay. I also, let me say this before I forget, I did also post a bunch of YouTube videos, you know, so the more videos are up. I was going to post more today, but it says I have to wait 24 hours because I guess I reached like some kind of limit, which I didn't know there was such a limit, but in 24 hours, they say I should be able to post more videos, so, okay. All right. Anyway, so going back to the notes, okay, right? We can graph the 2 lines. We have x plus y equals 4. We also have x plus y equals 2. Is it backwards? Yeah, no, I'm right. So, but you can see, you know, you just type in the graph, the equations, that is. What's nice also is you don't have to get y in terms of x. You know, Desmos, I guess, is smart enough to know that I'm going to graph it as y in terms of x. So anyway, here you can see that the graphs, they're never going to intersect each other. okay? That is, the lines never intersect, they're parallel. So what does that tell us? No points of intersection. No points of intersection, okay? So because of that, the system has no solutions. So graphically, we can see the system has no solutions. Okay. All right, so now let me get back to, let me get back to the notes. I know I'm jumping back and forth like this. So, what the? Oh, there it is. Thought I lost the notes, but they're right here. And here we go. All right. Good. Okay. So I figured now it'd be good to do another example. Originally, in the next one, I was going to have you guys try it, try graphing. But for time consideration, let me just, and since we're at the beginning of a lecture, let me just dive right into the answer. So basically here we have these two, we have this system, okay? So we're going to solve it by graphing. I mean, I did graph it in Desmos and I pasted the picture here. Let me just make that bigger if I can. There we go. But basically, if you graphed it in Desmos, you would see this graph. And you can see there is a point of intersection. It looks like it's the point 0,2. In the other class, I had a mistake here, actually, and it might be on the notes I sent, so I'm sorry about that. I think one of the equations I had, I think on the right-hand side here, I had 4, but it should be 2. So I am sorry about that mistake. But basically, this is the system. This is the point of intersection, though. So in other words, this is the only solution to this system. Remember, there's always 3 cases. There's one solution, no solutions, or infinitely many with a system of linear equations like this. So we only have one solution, which is the point 0,2. But again, in the notes, I think I made a mistake where 2 here was a 4, I think, but it should have been a 2 like this. So I am sorry about that mistake. Okay. All right. So we have that example. So what I want to do now is move on to another one. So here, as you can see, we're going to solve one by substituting. Okay. What I just deleted was a little bit of ink from, PowerPoint, that is, but I want to draw it for you guys. So I want you guys to see me draw it, that is. Anyway, so here's another example. We're going to solve it by substituting. And we could check our graph by Desmos. Again, that's what I'm going to do here. I'm mostly going to use graphing as a check because we have Desmos. All right. And again, with Desmos, you could download it onto your smartphone. You don't have to, but you could. All right. So here we have these 2 equations. Now, what we can do is for substitution, we want to get one variable in terms of the other. That's substitution. Now, from the first equation, I would try and get x in terms of y, as I'm doing here. Now, you might be thinking, why am I doing that? Well, look at the coefficient of y. It's a 3. If you try to get y in terms of x, you would end up dividing by 3, -3 actually, and you would end up having fractions. Not that that's wrong, but I think it's easier to get x in terms of y because the coefficient of x is just 1. So that makes the calculations a bit easier. So that's what happens here. All right. Now, so we get x in terms of y, right, from the first equation. That's pretty simple. I just add 3y to both sides, as you can see. Okay. And we get x, yeah.
So it doesn't matter. So you could get x in terms of y or y in terms of x?
Exactly. It doesn't matter.
Okay. Thank you.
You're welcome. Awesome question. Right, so yeah, you can get x in terms of y or y in terms of x. It doesn't matter. If you do everything correctly, you'll get the same answer. You'll get the right answer. So great question. So from here, we have, right, so I add 3y to both sides. And we get x is -1 plus 3y. So that's what we get for x. So what do we do next? We substitute, hence the name of the method. We substitute into the second equation here, as you can see. That's what I'm doing here, right? We have x. I'm plugging it in to this equation into the second equation, okay? And what we get is this. Okay. You want to make sure you use the other equation. We're plugging this into the other equation. If you plug this into the first equation, which we used to get x in terms of y, that's not going to get you anywhere. So we have 2x minus 3y. Okay. So now we substitute for x and we distribute. Right? We're distributing 2 times -1 plus 2 times 3y minus 3y. And that gives us -2 plus 6 times y, okay, minus 3y. So you plug it in and distribute like I'm doing. You end up with -2 plus 3y. Okay, now what do we do from here? Well, remember, 2x minus 3y is equal to 7. And since we substituted, this has to equal to 7, as you can see. So this is what we get here. And now we're good, right? Because now we have one equation, we have an equation in one unknown. So now we're basically back in chapter 1, at least with this equation.